Hello, my name is Steve Bowler, and in this video I'm going to be configuring RIP version 2. Specifically in RIP version 2 we're going to be taking a look at RIP summarization and offset lists. I'm going to show you how to configure summarization and also to configure offset lists. And what offset list is in RIP version 2 is it's a way to manipulate the RIP metric. As we all know, the metric in RIP is hop count, and we can use the offset list feature set within the Cisco command line to manipulate the metric inside of RIP. So we can make the metric higher, but you cannot make it lower with the offset list feature. So for instance, router 2 to router 1 is just sending a couple of network advertisements. It can, using the offset list feature on router 1 or 2, you can add to the hop count, but you can't take away. Okay, so let's go ahead and get onto the routers and do some basic configuration here. Router 1 and router 2. Let's just go in and enable RIP. Again, you need to put in the version number as 2 here so we can send subnet mask information to our neighbors. There's other features with version 2, but that's one of the main ones. Also here we're going to do a no auto summary so that we're not summarizing in the classful network boundary. Again, on router 2, serial 00 is going to router 1, and serial 01 is going to router 3. Again, here you can see version 2 for RIP, no auto summary, and later on we're going to be running some of the networks. I just haven't put any in there yet. So router 3. /24, just no shut. Version 2 under RIP, no auto summary, and now we could just ping across to make sure we have basic point-to-point reachability. 23.2, which is router 2, we have connectivity there, and from router 1 to router 2 we have connectivity there. So now that we have connectivity from the routers, except for, of course, router 1 and router 3, there's going to be no reachability yet because we haven't set up the network statements inside of RIP, which allows us to advertise networks to our neighbors. So what we're going to do here on router 1 is we'll set up a couple loopbacks. 172.16. 1.0/24. 172.16. 2.0/24, 3.0/24, and actually, you know what? I can already see a problem. Make sure that we can make this summarization as clean as possible. Do 172.16.0.0. That way we can summarize a lot better, and I'll show you later on how that's going to work out. So router 1 is going to have the following interfaces: loopback 0, loopback 1, loopback 2, and loopback 3. Put it down here, make it look better. So in this case, what we're going to do later on, once we get RIP up, we're going to be advertising a summary to router 3 from router 2. So router 1 is going to be advertising these networks. Actually, we could just send the summary to router 2. Either way, it's going to work. And then from router 3, let's just put in a couple of networks here. Loopback 0 is going to be 10.0.0.0/24, and loopback 1 could be the 20 network or the 11 network. Doesn't really matter to us. Okay, so let's go on to the routers here. Router 1, set up these loopbacks real fast. Only take a second. Okay, so alright, router 1's got all the loopbacks. Now let's just go into router 1 and do a router RIP, and we'll advertise the networks in now. So number 1, we want to advertise the directly connected interface, so 192.168.12.0, and then we'll advertise the specific loopback interfaces here. So 172.16.0.0. Oh, I'm sorry. That's actually all we need to do for that, since it's Class B. And let's go to router 2. Go into the RIP routing process and do network 192.168.12.0, which is our connection to router 1, is what we're going to advertise in the RIP, and the 23 network, which is our network to router 3. And that should be good. We're not advertising any other interfaces or anything into RIP from router 2, so that should be enough for router 2. And from router 3, we'll go ahead and do set up the loopback interfaces. Loopback 0 is going to be IP address 10.0.0.1 with a class, /24. And loopback 1 is going to be on the 11 network here. Okay, now from router 1's perspective, what we should see is router 3's loopbacks, if we've set this up correctly. Actually, let's see. No, we haven't set up on router 3. Let's go back to router 3 and advertise our networks into RIP. Do network 192, 168.23.0. That's the directly connected interface to router 2. And then we're going to do network 10.0.0.0. So this is full class A, and 11, two class A's. However, now if I do, let's just go to router 2, and we can verify from router 2 if we have connectivity. If I do a show IP protocols, see here we're having routing information sources, so we have a connection to router 1. Distance, of course, is the administrative distance is 120. That's default for RIP, and we're seeing the gate. Also, another gateway is router 3. As you can see here, we're also sending and receiving RIP version 2 out both of the serial interfaces on router 2. And of course our RIP timers. So, okay, for router 1, if I do a show IP route, see here now that I am learning of the 10 network and the 11 network that router 3 is advertising. We're also seeing the connection between router 2 to router 3. So if I go ahead and try to ping 10.0.0.1, as you can see there, we're successful. Also the 11 network, looks like we're good to go there too. So let's go to router 3 and see how the routing table looks on router 3. Again, if you want to just see the RIP networks in the routing table, just do a show IP route RIP, and as you can see here, we've taken out, like the directly connected interfaces. So we'll do a ping. We can see here that we're learning all the networks from router 1, so we'll do a ping 172.16.0.1. Make sure we have connectivity. We'll just do a couple of them. And as you can see, we have full reachability. And you can see here the hop count is 2. So, as you can see there, we have 2 hops, of course. For router 1's got to go to router 2, so there's the link here, and then the link between router 2 and router 3. So, of course, hop count is the default metric for RIP to find the best path throughout the network. Now what we're going to do is, as you can see here in router 3's database, we have show IP route RIP. We can see that we have 4 networks. As you might be able to determine, the routing table can get a lot bigger than that based on the amount of subnetting that you're doing and all the networks that you have going on. So what you can do inside of RIP to ease the burden on your router processor and your routing table, all the networks, is you can perform summarization within RIP. So we're going to perform summarization, RIP summarization on router 1. We're going to summarize these 4 networks into, and we're going to advertise just one network out to router 2. And then router 2 is going to pass that single routing advertisement on to router 3. Because if we look on router 2, if we do a show IP route, you can see here that we have the 4 routes as well from router 1 and the 2 routes from router 3. Okay, so let's go to router 1 and perform summarization. Now we're going to go actually under the interface to perform summarization, and the command is iprip hold on, let's see. I'm having a brain fart here. There it is, IP summary address, and then RIP. As you can see here, you could summarize just like everybody already knew who's watching this. with EIGRP as well. Summarization is performed on a per interface basis. So we're going to do IP summary address RIP, and then we're going to put the summarization. And as you can see here, we have 4 networks that we need to summarize, 4/24. So we can actually, just looking at that real fast, we can put that into a /22. Again, how you get to that is if we were to think of the lowest amount, the lowest network possible that's going to advertise 4 networks, you just the way that I do it, it's kind of probably not normal, but I can just look at it and determine, okay, that's a /22 just on the simple fact of just doing the math. 128 is 1, 64, 32, 16, then 8, and then 4. So that's 6 bits that we're going to have in the subnet mask, right? So we're going to take the so what we're going to do is we're going to take the sorry, did I do that right? Let me see here. Yeah. Okay, so what I did, I just opened up WordPad real fast here. The network in question again is 172.16.0.0 through 172. Let's make that a little bigger so everybody can see. 172.16.0.0 to 172.16.3.0, and we're looking at summarizing those 4 networks. The way that I look at this is we're working with the Class B network, so that's 16 bits for the network right off bat, and the way we're going to do this is we're going to look and see how we can send this across with the minimum subnet mask as possible. And the way I do it is I just do 128. Let's do it like this: 128, 64, 32. Now this is probably not what they teach you in subnetting class, but what works for most people. I mean, just find out what works for you, and this is what works for me. Is I can pretty much just look at it and see, all right, this is what I got to do. So what I'm doing here is I'm taking 128, 64, 32, 16, 8, 4. So of course we're going to use the 4 because that's how many networks we have, is 4 total, right? So that being said, how many subnet bits is that? That's 1, 2, 3, 4, 5, 6. 6 subnet bits in 16. Alright, so you just take 16 plus 6, and that's going to equal us a 22, or /22. And that's going to look like 172.16.0.0, 255, 255, 252.0. So this should be our network that we're going to be putting into our summarization and RIP there. Again, not the way they probably teach you in the CCNA or CCNP courses on how to subnet, but this is the way that I found is the fastest and the most reliable. I can just by looking at it, it's pretty easy. You just calculate, okay, how many what's the lowest amount of subnet bits that we can use, and then we just pretty much go from there. Find that. As you can see, say we had the following networks, 172.16.0.0 through 172.16.7.0. again, so you're needing to subnet, if these are all /24s, what you're going to need to subnet here is 8/24s, right? So the way you do this, again, I just, 128, no, 64, no, 32, no, 60, no, 8, yes. So 8 goes perfectly into this, so what we'll do is we'll use 1, 2, 3, 4, 5 bits. So again, so you're just going to do 16 because it's a class B plus 5 more bits is going to be 21. So what we're going to be working with here is /21. Again, if you write this out, 172.16.0.0, 255, 248.0. Another way to look at this is just really, you're just going to add, okay, 248.0. I just add 8 to that and I get 256. Here, if you add 4 to that, you get 256. But anyway, I mean, once you get it down to where you can look at it like this and just tell this, what the subnet is, you're in good shape. So let's go back here and do that real fast. Let's put in the subnet. Sorry about that quick subnetting. I'm not really good at teaching subnetting, so it's, I just understand it. So let's go back into here. Now our summary address here that we're going to be sending to router 2 is 172.16.0.0, and the network mask is 255.255.252.0. Again, if we look back in the document, that's what we came up with here, doing our our wicked subnetting routine there. Non-standardized, I guess is what you could say. Okay, so here we go. IP summary address, RIP, and 172.16.0.0, and then our subnet mask, and that should be it. So now router 1 should be sending out the interface serial 00 here to router 2, the /22 subnet for the 4 networks here. So now if we go to router 2 and do a show IP route, of course it might take some time because RIP is kind of slow propagating through the network. So we'll just give it a minute there to replicate. And there it is. Actually, there it was all along. I just wasn't seeing it. So as you can see here, we have the summary now that we're seeing, and that is marked here with the /22. Remember, this is the summary route that we are learning from router 1. Let's go to router 3, do show IP route RIP. As you can see here, we're seeing the summary /22 now, which encompasses the 0, the 1, 2, 3 networks. As you can see, our dead timer is about to expire. Actually, we just got another update. And as you might be seeing, well, why is there this many routes in there? If you just wanted the /22, now you have, now instead of 4, you're seeing 5. So that summarization really doesn't make sense. But we'll just give it a second here to replicate. As you can see, if you're still not seeing replication occurring in those other routes, you just do a clear IP route asterisk. And now if I do a show IP route RIP, as you can see, I'm only learning the /22 now. But I'm still able to ping if I do a 172.16.0, I'm sorry, yeah, 0.1, still able to ping that subnet, 2.1, 3.1. So everything within that /22 subnet that we were summarizing on router 1, sending to router 2 and 3, we can still reach it. However, it just doesn't show up with those single /24s in the routing table. Now we're only just seeing the /22, which is exactly what we wanted to do. Same thing here now on router 2, we're just seeing the single /22 within that network, within the 172.16 network range. Okay, so that's pretty much how to summarize within RIP. Pretty straightforward and easy to do. What we probably want to do now is show you guys how to use the offset list. So what I'm going to do is show you how to do that. Okay, so what we're going to do here is on router 1 we'll just do a show IP route RIP. As you can see here, we're learning the 10 network and the 11 network from router 3 through router 2 with an administrative distance of 2. Okay, so what we're going to do here is on router 1 we're going to modify the offset, the RIP offset inbound to the 10 network. So first thing we want to do here is just configure an ACL. It could just be a standard, so just do access list. We'll just do 10. So 10 kind of signifies the represents the 10 network. So access list 10, and then we're going to do a permit 10.0.0.0 and then 0.255, 255, 255. And then what we'll do here is we'll go into RIP, so router RIP, and we'll do the command is, as you can see here, offset list, add or subtract offset from RIP networks. So what we're going to do is add, so we're going to do offset list, and then here it's going to call the ACL that we just created, which is ACL 10, and then we're going to offset inbound our incoming updates from, and we're going to set the offset here. So what we'll say here is offset list 10 in, and then we'll offset it something like 8. So we're going to add a metric of 8 to the RIP administrative distance hop count, and of course that's going to be inbound. It's going to be looking for a serial interface here. If you don't put any, it's going to do it on all interfaces. So we're just going to say here serial 00. So now that we have the offset list applied, if we do a show IP route RIP, still see here that we're showing 2. Let's give that a minute. And if you're still not seeing, the offset of the administrative distance, what we can do is just do a clear IP route asterisk, and that'll just do a refresh and of our routing table. And now what we can see here for the 10 network is we can see an offset of 10. So the offset list really added a metric of 8, as you can see above here, as specified in the offset list command. Again, this command offset list 10 is going to call ACL 10, and in ACL 10 what we did is we permitted the whole Class A 10 network. So anything in the Class A 10 network, we are modifying the inbound updates from this 10 network, and we're adding 8 for the hop count. So it really looks like instead of 2, it's just adding 8 to that. And as you can see here now in our RIP database, or I'm sorry, in our routing table, you can see here for the 10 network we're actually seeing a metric of 10 for RIP 120. But as you can see, in the same time, updates are still coming in serial 00 for the 11 network, and they are only showing 2 hops. So what I'm going to show you here is you can actually set the offset of the metric high enough that the route will be discarded. So we can still ping. Let me just show you how we can still ping the 10 network, 10.0.0.1. We can still ping it. What I'm going to show you here is, well, we're going to create another offset list. Actually, I think you can only do. Let me just verify this real fast here. Yeah, as you can see here, we can only have one offset list at a time. So what I'll do here is I'll take that offset list out of there. If I can spell this right, go ahead and do no. So let's do a show run pipe to begin with RIP. Okay, so here we go. Now you can see we don't have any offset lists for RIP, so if we go back here and do show IP route RIP, see here now that the metric is back to 2. So let's go back here. We'll set the offset list the same. So we'll do offset list 10 8. Offset list 10 inbound 8. So we're adding 8 to the metric on 000 for the networks that are in ACL 10. So let's go back here and do a show IP route RIP. As you can see, the metric has changed again to 10. So we're going to leave this one the same. What we're going to do is now we're going to go to router 3, and I'm going to show you how you can basically set it outbound on router 3 to router 2 and router 1. So for router 2, if we look at the 11 network, we're seeing it, of course, just 1 hop away. So on router 3, we'll go here and we'll just create an access list 11. We're going to permit the 11 network. And what we'll do is we'll go under RIP and we'll do offset list. And then here again it's going to call an ACL, so we're going to call ACL 11, in which we permit the whole 11 Class A network. So we'll do offset list 11. And we're going to do outbound because we're going to be sending these networks out. Router 3 serial 00 out to router 2 and 1. So we'll do offset list 11 out. And we'll do an offset of 14. And put in the serial interface. And that should be it. So now what we'll do is we'll go to router 2 and do a show IP route RIP. Do a clear IP route. And now what you can see here is that we have a metric of 15 on router 2, and on router 1, if I do a show IP route RIP, what you're seeing is the 11 network is now gone. And this is because of the way that RIP works. If it's more than 15 hops away, as you can see here, the network is going to be discarded. So this is a way you can filter. Say you get a task, router 3 is advertising the 11 network. Advertise this network to router 2. However, do not advertise this network to. However, the 11 network should not show up in router 1's routing table. And then then you'll have something that says, do not use, a distribute list on router 1 or anywhere else in the network, and do not use an offset list on router 1. So the only way you could do this is really they're just trying to corner you into changing the offset or creating an offset list outbound on router 3 with a metric value of 14. That way, when the route for the network, the 11 network, gets to router 2, you add 1 to the hop count, making it 15. So it's reachable via router 2. So if we do a ping 11.0.0.1, as you can see, we have connectivity, reachability to router 3. And then if we look again in router 1's database, you can't see it. So if we can try to ping it 11.0.0.1, but as you can tell, we don't have reachability. Again, let's see if we can see this action on debug IP RIP. So we'll do a clear IP route on router 2. Okay, let's see if we can stop this fast. Now you can see here we're sending requests out, via multicast. Again, that's RIP version 2, use multicast. You can see here that we're receiving the networks. We're receiving the network, the 11 network, and we are sending it out with a metric of 16. Now I wonder if we go to router 1, do a debug IP RIP. Now here we'll do a clear IP route. As you can see here, now we have, oops, sorry about that, guys. As you can see here, now we're getting inaccessible because of the hop count, which is the max. It's exceeded the max, so 16 hops is inaccessible in RIP, and we can see that route being propagated. On R2, it's incrementing the hop count to 16 for. I'm sorry. It's seeing 15 hops to the 11 network from router 3. Then it's actually sending it out to router 1 with a metric of 16. Router 1's seeing it inbound the 11 network with the hop count is 16, and it's marking it as inaccessible. That being the case, again, here if we do a show IP route RIP on router 1, we do not see the RIP network we do not see the 11 network from router 3 in the routing table. So again, we've taken a look here at using the offset list feature outbound to modify, the administrative distance or the metric. I'm sorry, not the administrative distance. Modifying the metric of RIP. We've also seen here on router 1 how to use an offset list inbound to modify the metric, which is hop count with RIP. Also, we looked at on router 1 using RIP summarization. We summarized these 4 networks here into a /22 and sent that out. As you can see here, show IP route RIP on router 3, we're seeing a /22 now. So, hope you guys have enjoyed this video, and I hope you'll be with me with the next one. Thanks.